Hello guys, welcome to lab report number 7. It's February by now, and the last lab report was I guess at some time in November, and this is of course not how I originally intended this. I actually wanted to do this every other week or so, but yeah, man, my life hasn't been the easiest in the last weeks, and there have been a lot of delays in everything that I do here, and of course a delay in uploading new content as well and so on, and I don't want you to burden you with the details. I might tell you about that once I'm through with all this, but just believe me that I'm not in the easiest time of my life right now. But let's get to the positive things. That's what I want to focus on today, and two things will be what we're talking about today, and that is the EDM power supply unit and the progress that I'm making on it. And second, we will have some kind of mailbag Monday today. And in Germany it's still Sunday, but as my phone tells me, it's already Monday morning in Sydney, Australia. And call it a long shot, but I guess that some of you will understand, or most of you actually, why Australia might be the country of reference when we're talking about Mailbag Mondays. Okay, but let's get to it. On the left hand side, of course, you can see the EDM power supply unit that I've been working on so far. I've been showing this to you in several other episodes in the last weeks. And as a refresher, the EDM power supply is basically a high power signal generator that will be used to power an experimental setup for an electrical discharge machine in Canada that is worked on, or that will be worked on, by AVE. And this unit basically works like much like a crossover from a lab power supply and a signal generator, in that it spits out a pulse width modulated direct current that can be adjusted in the on-time voltage, the switching frequency and the duty cycle independently, as well as in its maximum current. So it has a current limiter, much like a typical lab power supply. But it also has several protection circuits, like for example a overcurrent protection circuit, and it also has over temperature protection and so on. And I would say that the whole device is about 95% finished right now, but I'm actually a little bit frustrated with it, because I actually wanted to ship this to Canada 2 weeks ago, but yeah, sometimes the really tough problems come up when you want to get everything just right. And the only thing that really still makes problems is the current limiting, and that has somehow to do, or I know what the issue is, but it's hard to explain. It has to do with the variable output frequency of the switching frequency of the output signal, and the control circuit of the boost converter stage. The current limiting mechanism that I'm using at this moment generates some kind of unwanted oscillations in the circuit, and that is something that I still have to work on. And because I think that will take some longer time, I actually just started to build a second unit, which I would say is about 60% finished, even though I just had a few days for that. So 95% 1 year and 60% a couple of days. So you can see that I have also learned a lot while doing my experiments on the first unit. And this is what is now going to be sent to Canada once it's ready, while I will have more time to work on the actual unit. But this second experimental unit will be even better for the experiments actually, because it will operate within even wider parameters. For example, it will have a maximum output voltage of 100 volts, which also comes a little closer to the initial goal. and it does not work on a boost converter, but on a buck converter principle. The switching converter is already, I'll say maybe 50% ready. There's still a lot missing in there. But the thing is here that other than the original unit I was working on, this device will not be capable to run on a 12 volt DC power supply, but it runs on a 100 volt DC system, which is powered by 120 volts AC and so on. But don't let me bore you too much with the details here. The thing is that this that the switching MOSFETs inside will have to switch currents in the range between 1 and maybe 10 amperes, and on the 100 volt side only 3 amperes, while we are talking here about average switching currents of 30 amperes and more. So one advantage of this design is that the circuit inside is much less volatile. And that's another problem that I haven't been talking about yet, but on the last weekend alone I had to repair this device for 2 times, because the main switching MOSFET, even though it's a super rugged, super expensive piece, basically has went up into flames a couple of times, because the boost converter circuit is more volatile than the buck converter circuit inside this device. Also, the switching currents, as I said, are much higher. Which really, if you make the smallest mistake in tweaking or redesigning the control circuit, that can result in basically the main power electronics components blowing up, which will not happen in this device, and that's why it's also much better to be experimented upon. And long story short, I will more time, and I don't know much how much time. So I will complete this first, send this to Canada, and that will give AVE the possibilities to perform his experiments. Then tell me which has to be improved upon, which parameters are actually what he needs. So which kind of frequencies, what kind of voltages does he actually need more voltage? Maybe the output voltage has to be higher, and so on. It's something important for you to understand. I'm just working on what I've been told. I do not have an electric discharge machine experimental setup in the lab, at least not at this point, so I cannot put this to a test. It has to be sent to AVE first. But okay, I've been talking a lot about this lately, and enough of it for now. Let's come to our Mailbag Monday then.
I didn't know they wanted an iPhone until they put it in the window.
Okay, today we have a package, and this time from another YouTuber, Rinoa Super Genius from Illinois in the United States, sent to me in Germany. So let's take a look inside. And you can sure say that he did a good job packing this. And again, some more fume in here. Okay. Let's see if there is some kind of message on here. Yeah, it really looks like it. Let's take a look inside. Oops, it. Okay. Hello TPAI. I know you're a fan of old tools, and recently AVE sent you a spare of his famous Rustall minus wrench. That's a nice hammer wrench and all, but a far superior wrench has to be a late 19th century's Coase wrench. Along with this letter, I have included a genuine Coase wrench that is in rough shape and may be in need of a bit more cleaning. I enjoy your videos a lot and would love to see this wrench in your collection. Perhaps you can compare hammer wrenches, Rustall versus Coase. Sent from my 1961 IBM Selectric typewriter, Rinoa. Gotta love it. Okay, let's take a look inside. Take out this goodie. Oh boy, looks good. Oh, it's kind of heavy. Ooh, wow, this is a true beauty, man. Just look at the the surface, you know, just look at the beautiful color and shine of this metal and these little marks, you know. It also says something. Says manufactured under Elco's patent deal. Okay, this is really cool. Wow, and it's even it's also very light to move, you know. Just beautiful, really cool. And this looks like from some kind of movie or video game, really. So here they are coming both together. The Canadian and the American model. Okay, and how can I not see it? On the other hand side of the hammer we have some more writings, and it says, if I read this right, Coase Ranch Corporation in Worcester, Massachusetts, USA. And you might remember a while back when I made that video about that clamp from the UK, you had that place called Worcestershire, but I'm quite sure that the Americans will not pronounce this Worcester, right? This is called Worcester over in Massachusetts, right? Just leave a comment about that if you're from that region or whatever. But please visit Rinoa's channel, because thank you, man. I love this tool. It's one of the oldest in my collection now, and this is, of course, living in Germany, something really rare. I love it, and I already bought something for you that I will send to you soon, and we will have to talk about that. But you guys out there, I insist that you visit his channel and become a subscriber of that crazy guy. A little crazy, and not more crazy than me actually. He's got a lot of interesting videos. He's interested in old tools just like me, electronics and so on. So please visit his channel. You can find a link to that in the video description. And before I go, I just want to mention it that I also got 2 packages from 2 of my viewers, one from the Netherlands and one from Switzerland. And I just want to tell you, rest assured, your stuff will be coming up in some future episodes. But I just don't have the time right now to do some more video editing and put that into this video as well. Just know that I'm grateful for what you sent me, and that I hope that I can use these things in future projects. But at the moment, as I said in the beginning, I have a lot of problems and I have to take my time and work on them. So I really want to make another video soon, maybe another lab report, maybe your stuff will be shown in that. I'm not sure certain yet, but I sure hope to see you all soon.